Welcome to our SQL learning session. Today I'll be talking about creating tables for database for developers. In this learning session, I will talk about first 7 modules, which are creating a table, viewing table information, write, table organization, index organized tables, write, and external tables. Let's go through the creating table, the first module. To create a table, you need to define 3 things: its name, columns, data types of these columns. The basic syntax to create a table is this, as shown on the screen. Now let's try a statement. It is create tables toys with 2 columns, toy name and weight. Toy name is a varchar 2 with 100 length, and weight is just a number. Let's run this. What happens? A table has been created. This is the first module. Now second step is to view the information about a table. Let me read this, what is mentioned here. Data dictionary stores information about your database. You can query this to see which tables it contains. There are 3 key views with this information. User table, all table owned by current database user. This is the smallest set of user tables. All tables your database user has access to. Sometimes you can have access to more tables even though you don't own it. So it is a bigger set than user tables. DBA tables, all tables in a database, only tables if you have DBA privileges. Thing is here is that you have even access to more tables. You have access to all the tables. Not only the access has given to you, but you have access to all the tables. Following code will show you the toys table you create in previous step. Now we are accessing the user table and we look up the toy in that user information table, user table. We'll look up the user table and see what does it contain. That's the first step, and it contains only one table, toys, and that's a table. This is the table I own, and that's what's shown here. We'll explore what these columns mean in the other step. Now it is practice by learning by doing. We'll try to fill what this to do is. We want to create table with 2 columns. One is color and one is shape. Color is going to be a varchar 2 with a 10 length. Shape will be varchar 2 with a 10 length. And we'll try to look it up in our user tables table. And there it is. We can find it. Fourthly, we'll look at the table organization. Let me read what does it say. Create table in Oracle database has an organization clause. This defines how it physically stores rows in a table. The options for this are heap, index, and external. By default, tables are heap organized. This means the database is free to store rows wherever there is a space. You can add the organization heap clause if you want to be explicit. Now let me run an example query for this one. This query creates a table called toy heap with the clause organization heap, and then it looks at the user tables and looks up for this table toy heap and see what it contains for that. Let's run this to see what it get, and it says toy heap is IoT information is known. IoT is type is blank, external table is no, partition no, temporary no, cluster name no. Cluster is blank, not no, cluster is blank. So that's the information we get for this table. And it says the general heap tables are good general purpose tables and are the most common tables in Oracle table installations. Now moving on to module 5, index organized tables. Let me read what they say. Unlike heap table, an index organized table imposes order on the rows within it. It physically stores rows stored by its primary key. To create a IoT, you need to specify a primary key for the table and organization index clause at the end. Now for this, let me run an example query that's been provided. Create table toy lot. This table contains two columns, toy ID in integer primary key, and as I said earlier, you need to specify a primary key for this table, and the primary key has specified here as a primary key, which is toy integer with the type with toy ID with the type integer. And second row column is a toy name, this varchar2 with the 100 length, and at the end there is an organization index. And requirement also says that add organization index clause at the end. Therefore, we have a toy lot, toy IoT with the organization index. Let me go through what it says. You can find IoT in data dictionary by looking at the common IoT column IoT type. This will return IoT is a table is index or organized. Now let me look it up in the user tables and let's see what it say. No data found. Let me run it again. Why is that? Let me run this table and see if I did correctly or not. Now it's created. It was not created earlier. Let me run it again. Now it's running something. Now, module 6 is to learn by doing. We need to fill this up and run this query. Here, we need to type, what we need to type here? What do you think? The objective is to create a query such that we are creating an index organized table called bricks IoT. What should we type here? Correct. We should type organization index because we want to create a index table. Therefore, let me type it here, organization index, such that we can create a table with index. Missing an invalid column name. What does it say here? Okay. Let me try to run this again. Missing invalid option. I forgot to put a semicolon here. That's why it's complaining. Let me run it again. And it's running. Looks like it is running. And when I query the user table with the same name, bricks IoT, I get an IoT type as index organized table. And that's what we are looking for. Now we are at last model 7, external tables. Let me go through what it say. You use external tables to read non-database files on database server. For example, comma separate values files. To do this, you need to create a dictionary pointing to the location of the file in the server, use organization external clause, and state a directory and the name of the file you want to read. Here's the example query that's been provided. Let me run it. Here, the first statement says create and replace directory, and that's a requirement where you want to point to location or on a file in server. This is the path, or this is the directory where the file is located. Use the organization external clause. Have you used that? Yes, we have used organization external clause as required. And lastly, state directory and name of the file you want to read. After that, we are pointing to that directory here, and we are pointing the file we want to read from that location. And let me run this thing. It should give me error because the Oracle Live SQL does not allow external connections. There you go. It is giving me the error. But it should run it if you run on your desktop. That was for today. Let me briefly quickly summarize what we discussed today. We discussed about creating a table. We talked about viewing table information. We talked about table organization and index organized tables. And also, we talked about external tables. And we did some exercises to learn what we just discussed. Thank you so much. That's all for today. I will see you in next learning session. Welcome back to our SQL learning session. Today we'll be continuing creating tables, database for developer learning session. Last time we talked about from 1 till number 7 in these modules. We went through model 1 through model 7. Today we'll go through remaining models, that is 8 through 13. Before we do that, let me quickly create some tables that are necessary, which will be referenced in later models. I'm going to simply run them. I'm going to create these two such that if they are referred in later sessions, they are present in the memory. Now we have done that. Let me go through temporary tables module. What is temporary table? Temporary tables store session specific data. Only session that adds the rows can see them. This can be handy to store working data. There are two types of temporary table in Oracle database, global and private. Now, what is global temporary tables? Global temporary tables are tables that are visible to all the users of the database, but they only last till your session does. Once your session is completed, they are deleted too. To create a global temporary table, add the clause global temporary between create and table. Here's how it's done. This is a script. Create global temporary table. Create and table. Write global temporary and write the table description here. And let's run it. That's how you create global temporary table. Next one, private temporary table. What is private temporary table? Private temporary table are those tables that are only visible to your session. Other session in the database cannot see this table. To create a private temporary table, what you need to do is put private temporary between create and table keyword. For example, here in this script, you see private and temporary between creating table keywords. And you also need ora $PTT underscore before the table name to indicate that this is a private temporary table. This table has been implemented since Oracle Database 18c. Before that, you could not create private temporary tables. Let me run this script. Let me run this script. I created a private temporary table just now. Let's see what's inside this. Let's see what's the definition shown for this table in user table in our database. First one is global temporary table, second one is private temporary table. And we want to link the definition of this table in user table in our database. We have what you can see is that you can only see a row for choose GGT, which is a global temporary table, but you cannot see for private temporary table because the database does not write private temporary tables in data dictionary. Isn't that amazing? Moving on to partition tables. What is partition tables? Partitioning logical splits of a table into smaller tables according to partition column. So rows with the same partition key are stored in the same physical location. There are three types of partitioning available. One is range, list, hash. To create a partition table, you need to create a partition method, choose a partition method, set a partition columns, define a partition's initial partition. Following statement create one table for each partition type, as we just discussed. Here are the statements that create the partitions according to different methods. First one is range. Partition by range, toy name. It takes a toy name column and creates a range. That is, if anything that is less than B, then goes to partition P0. If anything that is less than C, then goes to partition P1. Next, it creates a new table which is partitioned by list based upon the toy name column. The values Sir Sir Strippy Pants goes to partition P0 while Miss Snuggles goes to partition P1. Lastly, toy hash is partitioned by hash of toy name, which initially creates 4 partitions. By default, a partition table is heap organized table. It is not index organized table, but you can combine partition with other properties. For example, you can have a partition IoT, which is index organized table. You can create an index organized table and do partition that as well, as is shown here in this example. This toy part IoT is an index organized table which is having partition using using hash function up to 4 partition. The database sets the partition column of tables to yes if the table is partitioned. Any table, such as user tables, have a column called partition, and it is indicated yes if the table is partitioned. Let me show you. Let me run this command script. No data found. Let me run few toy hash. Not sure why it has not been run. Let me try to run this. Now it should be good. Table has been created. Now let me run it again. Let's see what happens. There you go. These tables have been partitioned, toy hash, list, range. This table has been partitioned. Therefore, the partition column is indicated yes in all of those tables. And while in a user tab partition, you will see the partition name for each of these tables, associated with each of these tables. Now, moving on to some try, do it, learning by doing process. Let me run some commands and try to fill it. Where is this to do? Create table. The question says, come the following statement to create a hash partition table. How do you create hash partition table? First, we can go up and see how it's done before. Let me copy some example of hash partition table as we already did before. Here, you see the partition by hash and column name and number of initial partition. And what it's asking here, it wants 8 partition, not 4 partition. It wants modified, and you want to partition by what column? Brick ID. Now let me run this and see what we get. Indeed, we created a table that has been partitioned according to brick ID up to 8 partitions. How do you know how many partitions it has? Let me try to see if I can get the partition name for these as well. 8 partitions, correct? Let me run this and see how many partitions do we get. Brick hash, and there you go. It has brick hash has 8 partition, and it has been named sys partition name, and these names are created by system itself. I did not create those. Next, moving on to table clusters. Table clusters advanced topic. A table cluster can store rows for many tables in the same physical location. To do this, you must first create a cluster. Before you do anything, you have to create a cluster. How do you create a cluster? You create a cluster by writing the command create cluster and a cluster name, and inside cluster name you create a column that is common along the cluster, common between the cluster. Let me run this. Let me create a cluster here. Then you place a table in it using cluster clause of create table, and then you create table and put the cluster clause at the end of the create table command. Here you have toy name, which is column of the table, and that column has been placed inside a cluster in toy cluster, such that they are part of the same cluster. Let me run this again. The table do not exist. Didn't I run this earlier? Let me run this. Okay, the cluster has been created, and now let us create these two tables with the cluster association with them. It has been done now. Rows that have same value for any toy name in Toys class tab and Toys Owners class tab will be in the same place, in the same cluster. This can make it faster get a row for a toy, a given name for both tables. This is one of the way to speed up the processing or speed up the query of the tables. You can view details of cluster by querying cluster views. How do we do this? Let me show you. Let me run the cluster, select the cluster name from cluster user clusters, and once we have that, we'll just print out a user tables from there. It gives me the one cluster is there present, and if I look at the table name for user tables, it has a table name as well as a cluster associated with them. That's how you do it. Next, moving on to dropping tables. Dropping tables is removing existing table with a drop table command. Just add the table name you want to destroy. How do you do this? Let me show you. Here, let me run this table and see what we get. We have a table with a one value, to heap, and this table exists. Let me drop this table to a heap. Data dictionary has that table. Now let me drop this table and let me check again if this table exists. And the table is not found because we just dropped the table. That's how we do it. Now, the last module, learning by doing. The question it asks is, complete the following statement to drop toys table. We will drop toys table, drop table, toys, and we'll see if the table exists in data dictionary after we drop it. The table has been dropped and then no data found in the data dictionary. We are done with the modules. Let me quickly summarize what we discussed today. We initially reviewed what we discussed in last session from model 1 to model 7. Then we went and discussed about temporal tables, partitioning table, learning by doing, discussing about table clusters, dropping tables, and again did one learning by doing session. That was for today. I will see you in our next learning session. Thank you so much.